There's Pi-hole on my phone. I can access it from wherever. I can access my home documents, my home photos, anything on my private home network with... Hey everyone, Travis here from Travis.media. So traditionally, the tech resources of companies were managed on premises. There were servers, there were data rooms, and all of that ran the company's applications. To access any resources, you also had to be on premises and on that company's controlled and secured network. You worked in the office, in the building, and your corporate castle had a moat around it to secure the perimeter against outside attackers. And every now and then, someone would need to access that network remotely, which would require a drawbridge, better known as a VPN server. They establish connection to that server, prove they're an authenticated user, and they get access to the network. But times have changed. 2019 sent virtually everybody home to work. The moat became meaningless, and the walls came down. This perimeter-based defense with a VPN is now, if not obsolete, it's an insecure hassle. It's complex, it's hard to maintain and scale, and there's no granularity, which is an absolute necessity now that the walls are down and companies are employing people from all over the globe. And in these changing times, we've moved to a new model called Zero Trust. Zero Trust allows you to get rid of all that VPN architecture and the perimeter as a whole and exchange them for, well, nothing. Access is right there on the public web. But how is that secure? Well, because the network and any users who want to connect to the private resources on it, they're all assumed to be untrusted. Hence the zero trust. Every single attempt to access a private resource must be verified and checked continuously, ensuring that the user is who they claim to be, authentication, and is authorized to access what it is they're trying to access, authorization. So a perimeter, public network, private network, none of it matters. It's all untrusted. Perhaps you have a home network that houses all your media and your documents, and you want to be able to securely access this network when you're away on business. Or perhaps you're a team of 5 working on a top secret application together, and you need to control and delegate who has access to what while keeping it all private. Or you're a growing IT organization looking to ditch your VPN altogether, which you should, and easily adopt a zero trust global solution for all of your private infrastructure. Great! But setting up a zero trust solution from scratch, it's not an easy task. So today, we're going to look at how we can achieve a zero trust setup for our private data, our infrastructure, our servers, whatever. And to demonstrate it, we're going to be using a complete solution called Twingate. And we're specifically looking today at Twingate because, 1, they make it really easy to do all things zero trust, and they're leading the way in this industry. 2, it's free to use for up to 5 users, which is all many of us need. And 3, they've offered to sponsor this video. And as you know, I only work with sponsors that I completely trust, that I recommend and would use myself. So with all that said, let's get started. Here's what we want to achieve today on the surface. So we have some server or network or networks or infrastructure that's private. It can't be accessed from the public web, but people need to access it. And we want to control what each person can access within it. We want it to be insanely secure, and we want everything logged so that we can monitor that success. So we need something on the public web that keeps our infrastructure or our servers hidden, but facilitates authentication and authorization and access and policies and logging, etc. And to have users never touch our infrastructure directly, but have this access point do the work for us. But enough of this theory and subjecting you to my second grade design skills. Let me show you how all this works with Twingate. So head over to twingate.com and click on Try Twingate for free. Remember, it's free for up to 5 users. And then sign up with your Google, Microsoft, GitHub, or LinkedIn account. And then choose your network name. For me, it's just Travis Media. So travismedia.twingate.com. And once you're all set, you'll be on this screen. This screen, or admin panel, with its settings and policies and all of that, this is called the Twingate controller. It's one of 4 components that make up this system. It stores configuration changes via the admin console, it registers connectors, and handles a few other things. But for me and you, it's our home base. First, we want to add a remote network. There's actually some notes down here that will get you started, or you can click on this setup guide link that'll walk you through the process. So prerequisites, summary of steps, there's only 3. But if you're watching this video, I'll go ahead and walk you through it myself. So step 1, define your network. Add a remote network in at least one resource that you'd like to access. So let's add a remote network. I'm going to come up here to remote networks and click this plus button and add a new network. So I'm actually going to demo 2 in this video. First, I'm going to demo a private AWS network that houses an app I'm working on. And then second, I'll demo my home network, which is also private. So I'm going to choose AWS. I have an app that I'm working on and I want it to remain in a private network. Perhaps I want to pull in another dev or 2 to come help me out. If this was a VPN, they would authenticate and get access to my entire network. That's a no-no. With Twingate, I get to decide who can do what in my network. So I can have 5 apps, bring in 2 developers, and they only get access to 1 app. And that's only the beginning as far as flexibility. But we'll get there in a minute. Let's go ahead and create the network. So location is AWS. The name, I'm going to put Travis Media Resources and add remote network. Step 1 done. Next, we need a way for Twingate to access this remote network. My AWS subnet is private. Nobody can access it, but it does have a NAT gateway giving me outbound access, which is all Twingate needs. So where's the connector? Well, let's go to my remote network, and there's a section here called connectors. There are 2 of them. Twingate actually created these for me, and there's 2 of them in case you want to do high availability, but I'm just going to use 1. If I need 3, I can just click add connector. Now these connectors are intended to be deployed behind a firewall in a private remote network. So we have this remote network. In order for Twingate to access my private network, we need to deploy one of these connectors, or both of these connectors, whatever, into my private network. Now, how do we do that? Well, it's very easy. Let's go with the blue ferret. Step 1, select a deployment method. How do I deploy it? You get 10 options here. I'm going to choose today the AWS AMI. And then when I do my home network, I'll use Docker. Step 2 is to generate tokens. These tokens serve to authenticate the connector to this controller. Remember, our controller is the admin panel. Our connector is what we're deploying. So let's generate 2 tokens by clicking this button. And I need to authenticate to generate these tokens. Always a good thing. And I get an access token and a refresh token. I'll go over all the technical stuff behind this a little later in the video. For now, let's keep moving on. Step 3 is to customize this AWS AMI command. My network is in US East, Northern Virginia region. My subnet ID is my demo VPC private subnet. So I'm going to grab this ID, go back to Twingate and paste that in. Security group ID, it's optional. I'm going to go ahead and put it. So I have this demo security group that I want to use. Paste that in, and then I'm just going to leave the rest blank. So that's step 3. I just configured that AWS AMI command. If you scroll down, you'll see it's just filling in information on this CLI command that I'm going to use. So that's step 3. Step 4 is to run the command. I can choose my CLI environment. I'm on a Mac. I'm going to use the bash command. And you'll see my access token, refresh token, my region, subnet, security group. Twingate filled all that in. All I have to do now is just copy this command, open up my terminal, which is already authenticated to AWS, by the way, and just paste it in. Watch this. Paste, enter. While that's running, I'm going to scroll down and it says wait for connection. After running the deployment command, the connector should automatically connect to the Twingate controller and then the Twingate relay, which we'll talk about later. And then a note here, connectors only require outbound internet access. Like I said earlier, my private network has a NAT gateway, which only allows outbound access. So we're good. And if you want to further limit it, there are instructions here. And that's it. Let's go back and see if we've connected. So back to networks, click on my network, and look at this. Blue ferret is green and connected. It's that easy. Amazing. And if I look in AWS, under instances, I have a new instance initializing called Twingate Blue Ferret. So my connector is deployed in my private environment, and I'm now ready to move to the next step. What is the next step? Let's check our quick start. So we defined a remote network. We've created and provisioned a new connector. Now we can access our protected resources with the Twingate Client. So the client is the 3rd component of Twingate. The first one is the controller. Second one is the connector. The 3rd is the client. What is a client? A client is just something you download so that you can access this network from your computer or your phone or your laptop. So to do that, I'm just going to click this link. It says with your Twingate network configured, the Twingate client application allows you to connect to resources you are authorized to access. So I'm going to open that link and it tells me how to install the client. So visit this link here to install the client. There's a client for Mac, Windows, Linux, Chrome, iOS, Android. So I'm going to choose download for Mac OS. When I do that, it takes me to the Apple App Store. Open the App Store, and there it is. This is the client that you'll download on any computer, anywhere, to access the resources you've been given access to. So just click this to download it. And when you open it, you'll see up here at the top a new icon. If you click on that, it says log into Travis Media, more, or quit. This is the Twingate client. So I'll click log into Travis Media, sign in with Google, choose my account, and that's it, authenticated. The client's role is to act as an authentication and authorization proxy for user requests to private resources. It's simply how we access our resources remotely. So now that I'm authenticated, I can go up to this logo again, and there's a section called resources, and it says 0 resources. Okay. We haven't added any resources. So let's go back to Twingate and add a resource. To do that, just click on Create Resource, and we add in our IP address and a label. So in my private network, I have an app that I'm working on. It's just a Next.js app, and it's not accessible to the public. but we have the Twingate connector in our environment, which is going to allow us to access it remotely. So all I need is the IP address to this resource, which I've called community app private. The IP address, a private IP address, is 10.0.1.2.1.6. So I'm going to put that in as the address. You can also use a domain name. I'm going to put in the IP address. The label is going to be community app. And simply click create resource. What group does the resource belong to? Let's just choose everyone. We'll change this in a minute. And let's grant access to everyone in the everyone group. So now when I come back up here to the client, I have a new resource called community app. I can copy the address, which I'll do, or I can use this to open an admin console. So I've copied the address. I'm going to go to my browser, paste that in, add port 3000 because it's a Next.js app, and hit return, and there's my app. I can go and click around and whatever. But if you notice up here, it is at 10.0.1.2.1.6. I can access a private resource from any computer anywhere because I have the Twingate client and I'm authenticated and authorized to do so. Now if I go back to my resource here in the controller or the admin panel and I click on it, I have some logs that tell me what's going on. So Travis Media connected, show details, connection established, event ID, client device, resource, duration, and all of that. Great. I can now access my private app. And guess what? I just downloaded Twingate on my phone. You'll see it right here. And there's community app. So let me click that, copy address, go to a browser, port 3000, and there's my application. 10.0.1.2.1.6. Now let's disconnect from Twingate, disconnect. I refresh in my browser. And I can no longer connect. It's just sitting there churning. And in a minute, it'll time out. Really cool. So that's great, but there's more to it. Remember I said earlier that I may want to hire a couple of developers to come help me out and build this app? Well, I want to allow them into my private network, but I want to restrict what they can do. If I decided to deploy 4 more apps or I'm doing some other things in this environment, I don't want them to be able to access the other apps too. I only want them to be able to access this community app only. And there's a number of things I can do to really tighten up the security posture of my environment. First, I can go to my community app, choose edit, and instead of just allowing everything here, I can go to ports and I can only allow port 3000. I'm going to block UDP and block ICMP and update resource. That's all we need. We only need port 3000 for this. Next, I want to add these members to my team. So add user. I'm going to use one of my other emails and pretend this is a contractor. I've hired a contractor to come in and help me out. And I'll go to groups and I'm going to add a new group called contractors. Add the group, and I'll add this user to it. Add one user. This user is now part of the contractors group. I can also add a resource. So it says this group does not have access to any resources. I want them to have access to the community app. Add one resource. And on that resource, I can set a policy. So I can choose the default policy, or I can go over here to policies and create one. Let's call it contractor policy. Create policy. And then let's click on that. Here I can say they must authenticate let's say every 2 days. And they must have MFA. I can click here, MFA not required. I can require that they use an MFA, like Google Authenticator, biometrics, or a security key, like a YubiKey. But I'm not going to do that for the moment. And then, this is really neat. I can set device security policies, like minimum OS requirements, which are features that their device must have to be compliant to use my network. So if I go to manage, I can say, hey, any device can access my environment, only trusted devices, which we'll talk about in a minute, or we can set a custom device security policy. So I can say no iOS, no Android. Sorry, no cell phones. Let's confirm that. Then I'll go back to team, groups, contractors, and I'm going to set the policy of contractor policy. So my contractor is in this group that only allows access to this one app, and that contractor must be a macOS, Windows, or Linux device. Really cool. So let's actually test this out. I'm going to sign in as this contractor, which is just me under another email, and I'm going to use my iPhone, and I should be blocked. So this user is actually in 2 groups, I think. So let me take them out of the everyone group. And actually, I don't want anybody in this everyone group. Let me create a new one called admin. In that admin group, we're going to add the community app. Add me as the admin. And then back in the everyone group, we're going to get rid of this community app. Awesome. So let's just not use the everyone group. We have an admin group and we have a contractors group. So I'm going to log in as the contractor. sign in to connect, continue, sign in with Google, and I'm going to sign in as the contractor. And there we have it. iOS blocked because we have a device policy on that group not allowing mobile phones. Awesome. What you can also do is go to devices and go to security, and you can set device security overall. So for each device, you can set things that must be compliant. Screen lock not required, biometric configuration not required, HD encryption, firewall. We can set all these to required. They must have a firewall, hard drive must be encrypted, biometric configuration, and screen lock must be on all Mac devices, no matter what. iOS, Windows, same thing. They must have all of these things for anyone to enter my environment. Very neat. You can also set up a trusted profile. So if you go to create, let's create one for Mac OS. And you can set up a trusted profile with these well-known and trusted endpoint solutions like CrowdStrike, Intune, Jamf, SentinelOne. You can connect to them and let them verify this profile. Or you can do a manual trust. So there are trusted profiles as well. So you can go a step further in your security. And then of course, resource policies. We've already looked at that. And then if you go to settings, you can set the admin console security. So you got a couple of people using your admin console. You can make sure they authenticate every 1 hour. Or you can make MFA required, which everyone should do. Next, what if you want to use your own identity provider for this management? Are you using Okta or Azure AD? Well, you can connect to them right here under Identity Provider. So connect your identity provider, make team management a breeze. There's also device integrations, which we already talked about, secure DNS, it's all there. All right, before I add my home network to this thing, let's look at how this actually worked. Let's walk through what we just did. So first, we started out in the Twingate controller, which is essentially the admin panel. And with it, we can delegate authentication to social identities or configured identity providers. If you remember, I used Google to authenticate. Second, we deployed a connector in our AWS private network. It's intended to be deployed behind the firewall of a private remote network. The connector authenticates and maintains connectivity with the controller. These connectors are not accessible from the public internet when deployed and are not directly accessed by users. This means that your networks can remain hidden from the public with no visible exposed entry points. When we deployed this connector, it authenticated with the controller by providing those 2 authentication tokens we sent it. Now, if those tokens are valid, the controller responds with a signed, time-expiring message that includes a whitelist ACL specifying which resources the connector is allowed to forward any connections to for any user. It also includes the fully qualified domain name for the relay, which we'll talk about in a minute, as well as a token signed by the controller. Third, after deploying the connector, we downloaded the client and signed into Twingate from our own machine. The client's role is to act as a combined authentication and authorization proxy for user requests for private resources. It's where most of the decision-making takes place in a Twingate network deployment. The client handles user authentication, it proxies TCP and UDP traffic for protected resources as well as DNS requests. Fourth is the relay. This is the one piece we haven't talked about yet, and it's very simple. In fact, you have no control over it. It's part of Twingate's infrastructure, and it's available globally. The relay facilitates the establishment of a secure connection between clients and connectors for data headed to a resource. And this relay is responsible for establishing the secure peer-to-peer connection between the connector and the client. Even when peer-to-peer connection isn't available, Twingate has a backup that will operate in the transport layer. Let's quickly add a new remote network for my home network. So I'm going to go back to Network, Remote Networks, and add a new one. We'll do on premises and call it Home Network. I'm going to go there. Remember first, we deploy the connector. So I have 2 here. Let's choose Smiling Jaybird. And for this, I'm going to use Docker. I have a Raspberry Pi set up. Docker's running on it. Why not? Step 2, generate tokens. Let's generate some tokens. Authenticate, and we have some tokens. Next, we'll customize the Docker command. I don't need anything I need to customize. And then step 4, I just need to run this command. So copy it. So let me log into my Raspberry Pi, SSH, pi at pi4.local. It's just one that I set up. And let's run the command. So again, this command is going to have my access token, refresh token, and the information it needs. So paste that in, and let's run it. Of course, I got to do that with sudo. Then let's do a docker container ls. And we see our container is up and healthy. So let's check Twingate. Let's go back to networks, click on home network, and Smiling Jaybird is connected to my home network. And to let you guys in on a little secret, I'm not a big home network guy, but I do have Pi-hole running. Let's see if we can access that. So label, let's say Pi-hole. And then I can put my address, which is on my local network. And let me remove this HTTP part. And let me show you this. I can go to alias, and create an alias for it. Let's say piehole.home. How about that? Choose create resource. I'm going to put it in the admin group. So grant access to the admin group. Default policy, no problem. Now if I go up to my client, I should see I now have Piehole as a resource. And I have the alias piehole.home or my private IP address. Let's try piehole.com. So copy that and paste it in. And of course I need to do admin. And there's Piehole. Now I just logged in on my phone. You'll see right here, I now have Piehole. There it is. So I'm going to click on it, choose original address because I'm going to try piehole.com. I'm going to go to a browser. This is not connected to my home network. This is cell service and /admin. And look, there's Piehole on my phone. I can access it from wherever. I can access my home documents, my home photos, anything on my private home network with Twingate. That's awesome. Now this video is getting really long. There's just a couple other things I want to point out. Under team, there's a tab called services. And we can do a whole video here on services. But basically, services offer a way to provide programmatic, centrally controlled, and consistent access controls for automated processes like CI/CD and other custom applications. So definitely look into that. And the final thing is analytics and logging. Now, all proxies should be logging the actions of every user and everything that goes through them. And Twingate is no exception. Twingate actually logs all the network connections made between clients and connectors. In the admin panel, you can go to team and users. I can view the activity for each user. I can go back to the network and resources, and I can view any activities happening to the resources. So I can view individual users, I can view individual resources. And then there are real-time logs that you can set up and send to something like a SIM. You can also go to settings and reports, and you can export audit logs, user activity, and network events. Or you can sync them with Amazon S3. The options are endless here with Twingate, and I hope you're seeing the power here. Now, the last thing I want to mention is security. So a lot of people do not like the idea of having their sensitive information in reliance on the cloud or with another provider. That's not them. I get it. But Twingate has an entire page addressing their security that you should read up on if you have that apprehension. So twingate.com/docs/twingate-security. And it's written up for customers or prospective customers about Twingate's security posture, practices, and processes, both information security and product security. Give it a read. I'll put a link below to it. So I hope you found this video helpful. If you did, be sure to give it a thumbs up if you're still watching at this point. And if you haven't subscribed to the channel, consider doing so. And I'll see you in the next video.